Well, hello and welcome to our first aviation sustainability webinar of 2024. And this year, we're delighted to welcome our new series sponsor, Honeywell Aerospace Technologies. Now, many of the most important companies in our industry have chief technology officers or their equivalent. These are the men and women whose job it is to lead their businesses' technological endeavors, to champion innovation on the senior leadership team and oversee its delivery, and occasionally think the unthinkable. As we've reflected on previous webinars, there has rarely been a time in the history of aviation when the potential of disruptive technological change has been so much to the fore. And it's a job of my 5 eminent guests today to do the hard thinking on behalf of their companies about where the technological breakthroughs might be, what the investment priorities should be, and how they get from here to there. Now, we're not going to focus so much today on the products of the present, but on the technologies of tomorrow, and how the expert panel views the path to a net zero future for the industry in the 2030s and beyond. What are the key steps that we need to take as an industry to reduce our demand on carbon-burning fuels while meeting the ever-increasing demand for air travel and human connectivity? So just before I introduce our panel, a few housekeeping notes. We'll be live for the next 55 minutes or so, and there will be a chance to ask questions via the Q&A icon at the bottom of your Zoom dashboard. And I'll try and get through as many of these as I can. So, to our guests. I've known Luis Carlos Affonso for more than 20 years, but his time with Embraer goes back 4 decades. As Senior Vice President, Engineering and Technology Development, he spearheads the Brazilian company's efforts in that field. He also chairs the board of urban mobility offshoot Eve, and among his many roles in the past, he has pioneered Embraer's highly successful entry into the executive jet market. Dr. Todd Citron is Chief Technology Officer at the Boeing Company, responsible for developing and executing the US company's technology strategy. His remit covers technology ventures Aurora Flight Sciences and Avion X, as well as engineering oversight and support to joint ventures Whisk and SkyGrid. He oversees global teams working in 5 US and 7 international research centers. Russ Dunn is Chief Technology Officer at GKN Aerospace. Prior to joining GKN, he spent 17 years at Airbus, mainly in technical leadership roles, including leading the A350 wing engineering team from concept development through to flight test and certification. He assumed responsibility for GKN's sustainability strategy in 2019, and today drives GKN Aerospace's focus on sustainable technologies. Welcome. Todd Giles is Chief Technology Officer for Honeywell Aerospace Technologies, where his responsibilities include building relationships with customers and directing all technology and research and development activities. He joined Honeywell as a design engineer in 1998 and has held several senior roles, most recently as Vice President of Engineering within the Engines and Power Systems business. Sabine Klauke has been Chief Technology Officer for Airbus since January this year, a role she combines with being Executive Vice President Engineering of the commercial aircraft business. She leads a team of more than 13,000 employees around the world who design, develop, certificate, and ensure the continuing airworthiness of all commercial aircraft products and services. A 22-year veteran of the European group, she's held a variety of roles, including Airbus Chief Technical Officer and Head of Engineering for Airbus Defence and Space. So, Sabine, welcome. Perhaps I could start with you. Airbus has been very vocal about the promise of hydrogen propulsion as a key weapon in the campaign to reduce carbon emissions. Just very briefly, why hydrogen?
Okay, that's that's a wide question, actually.
It's a very
maybe
difficult question to answer in a few
take
minutes.
the chance, because yes, our journey is already 3 years in time now on this. And I mean, first of all, we do think that aviation is good for people, good for jobs, and hence good for prosperity. And the whole question about decarbonizing the aviation is then not the question of if we do it, but when we do it. And I think if we look at our commitment, and that's a commitment overall of the industry towards 2050 to be in the position to really decarbonize, we quickly come as well to the conviction that there is a growth overall, and we will not stop that. People want to fly, people need to fly, and if we look worldwide, that's something which we'll say. And then, yes, we need it all. We need to do continuous steps, but we will also need to go look for the new big technology steps to come really to zero. And that's where we see hydrogen. So then it's really going through all the different technologies that we can find on the way, being it improving the existing aircraft and systems in being lighter, being more efficient, and do that all over the place, starting by fleet modernization, by the way, because if you take an aircraft of today and you replace one of 20 years ago, you gain 20-25% in efficiency. And we are of the opinion that then you will need a kind of another 30% better aircraft on the way, and you will need SAF. You need it immediately, but with SAF you cannot go the whole, and then we need to really go zero, and that's with hydrogen. So I think it's not, is it hydrogen, and why is it hydrogen? It's hydrogen because we cannot get enough if we only do kind of the incremental steps. But it's hydrogen end. Yeah.
Okay. Well, we can certainly examine a lot of these themes later on in the webinar. Todd Citron, Boeing's perhaps been less enthusiastic about the potential of hydrogen, but you're looking very closely at, among other things, at aerodynamics and structures. Maybe tell us a little bit about the truss-braced wing studies that Boeing is involved in, and perhaps briefly too about why Boeing has invested in a number of technological ventures such as Whisk and Aurora.
Great. First, pleased to have the opportunity to speak with you and everyone else. And I think maybe the starting point is we have the investment, which I'll touch upon. To get to net zero by 2050, there's not one lever to pull. It has to be a combination. And so we think of it in 4 categories of fleet renewal and the ongoing improvement in aircraft, operational efficiency, just flying more efficient routes, as well as departure gating and so forth. Renewable energy, of which sustainable aviation fuels is one answer. Hydrogen is an answer. There's a range of possibilities there. And then advanced aircraft technology to drive improved efficiency. We see a lot of benefit from the transonic truss-based wing. We think that combined with other expected advancements, there could be up to 30% improvement because of the increased aerodynamic efficiency. But we really have to look at this full range of options. And I think what's really critical is we all want to make sure that we're making a positive difference, which means we need to look at the total climate impact of any one option. And that includes understanding the infrastructure and the generation of the energy that is then used to power the aircraft. And I think having that full calculus, which is something we do in our Cascade tool, is really important to know that we're having a net benefit in that regard. So definitely investing in transonic truss-braced wing, but definitely also interested in pursuing sustainable aviation fuel, range of options, including hydrogen. We flew our first hydrogen fuel cell powered aircraft in 2008. Operational efficiency with the demonstrations we did with the FAA in Asia on regional optimization, and then of course fleet renewal. So I think it's all of the above type of requirement.
Okay, and again we'll touch on a lot of these topics as we go on. The other Todd Giles, Honeywell works with almost every OEM across a range of product areas from avionics to engines. What are your technological priorities at Honeywell as we look towards the next decade?
Yeah, and hey, and I do want to say thank you, as Todd did from Boeing, right, for having me on this webinar. I think this is an extremely important topic for myself and for Honeywell and in general. But from I fully agree that there's not one single lever. And as you stated, Honeywell provides systems, we provide components, and we provide that across pretty much every aerospace market there is. So when we look at this, we have a very broad technological portfolio to support sustainability. First and foremost, right, how do we get our turbo machinery compatible with SAF, right? We have that today. How do you move towards hydrogen burning, as Sabina was talking about, for hydrogen propulsion? And then beyond that, what about fuel cells, right? How do we develop electricity on board the aircraft through generators, hybrid electric, any number of avenues? And then even beyond that, I would say, you know, how about flight operations, flight efficiency? How do we fly more efficiently in route planning, incoming and outgoing from airports, things like that? This is going to be a multifaceted approach to get us to where we want to be from an industry standpoint. And we here at Honeywell, especially Aerospace Technologies, investing in pretty much every one of those work streams so that we can support every market that needs to go to that net zero carbon. So we're very excited about this.
Excellent. Luis Carlos, Embraer, as I mentioned, has never been frightened to innovate, from the original E-Jet to Eve and executive jets, and even moving into clean sheet military transports with C390. What do you see as the transformative technologies being developed today that might change aviation in the 2030s? Oh, you're on mute.
Thank you very much. Thank you, Murdo. Thank you for the invitation. Big pleasure to participate of this FlightGlobal webinar. First comment I'd like to make: we at Embraer, we fully support, you know, the net zero carbon goal for our industry. So we believe we have to earn our rights to exist and to grow. So fully supports that. And well, as my colleague panelists mentioned here, we will need to use several levers to reach this very challenging goal. We believe the mission, we like to say that the mission defines the strategy. So the application, the capacity, the range will define which are the technologies that are best for the different applications. So at the moment, I believe, as an OEM, we have to understand and progress our knowledge and our readiness in all those levers that were mentioned, like 100% electric, hybrid electric, hydrogen fuel cell, direct burn, SAF, to create optionalities. It's a bit early to understand which of these technologies will succeed and how fast they will be ready. So our obligation as technology and engineering is really to be ready and to be in the forefront. So that's what we're doing.
Okay, thanks, Luis Carlos. Russ, finally onto you. You know, wing design is maybe overlooked as a major contributor to efficiency and environmental improvements. You know, what are your thoughts maybe on that area? And more broadly, what is GKN's sustainability strategy?
Yeah, so really good question. So GKN Aerospace is probably a company unlike a number of others, or any other around the world, because we sort of, you know, our approach is that we think like an OEM and we act like a partner. So we partner with all of the companies on the call today and others, GE, Pratt, etc. And I guess, you know, our belief is that, as Sabine said, you know, aerospace is a force for good. It's something which we're all passionate about. And companies that have got the capability to change the world for the better also carry the responsibility to do so. And we do that. We take that responsibility, even though we're not the OEM, and we don't have the aspiration to be the OEM. We are here to inspire, we're here to enable, we're here to support and partner with the best OEMs in the world in order to play our part and take our responsibility seriously. And we do that in every aspect of our responsibility, whether that's enabling delivery of the most efficient aircraft that are available today, whether it's in partnering on the next generation of engines and airframe programs, or whether it's indeed, going a little bit more ambitious in the world of hydrogen electric propulsion and creating our own concepts and our own architectures and proving capability, so that when our customers are ready, we can then offer real capability that can enable them to make the important decisions moving forward. So I mean, in terms of wing design, clearly that's a piece of what we do. It's also, we're also equally engaged on airframes and on propulsion systems. On wing design, I guess, a really important part of the overall efficiency of the aircraft, independent of what fuel type you want to use. If you can improve the aerodynamic efficiency and weight, it can enable whether it's SAF can go further or can provide you with better capability on other fuel sources. So yeah, an important enabler to all of the above.
Great, thank you for that, Russ. We've got so many areas to cover here that it's going to be difficult to know where to start and where to finish, but we'll give it a go. And we're starting to get some great questions in from the audience as well. So I'm hoping to get onto some of these a bit later. But let's maybe start with hydrogen, because this has come up in a number of the points that you've all made there. It's, as some of you said, it's just one of the levers, perhaps one of the possible technologies. But maybe if I could start with Sabine, what is the what is the potential of hydrogen if everything works with this technology? Where could we be, and how quickly are we talking about this as a workable technology for propulsion?
Yeah, thank you for the question. I mean, clearly hydrogen has a big potential to, I mean, if you look at kerosene, it's a very good combination of energy and volume and weight. I think that is really outstanding. If you then look, if I need to really replace that, what can I take? Yeah, and then you can look in a lot of different chemistries, and then hydrogen comes up as the one with, for us at least, the biggest potential. Volume and energy wise, it's not exactly the same. It's a bit different, but it has a very good potential. So this is why we chose to look at hydrogen specifically, if it is about the airplane and to really go net zero. So this is why this is our North Star. If you really want to emit zero CO2, it's about that. And then you still have two choices. Is it electric with fuel cells, or is it direct combustion, which is of course bringing you to different concepts. You asked, when can it be ready? So our clear ambition, and we are fully up to it, is to have an aircraft in the market, so a commercial aircraft in the market by 2035. And the roadmap that we've built is actually supporting this. So where do we stand today in regards to that? Clearly, we have put all the different technology bricks on the road where we need to mature them little by little to the different TRL levels, so the technology readiness levels, in order to be able to pick and to choose the right configuration for an aircraft program, and as well then to be able to fly it and to mature it. So we are in this run for the most important ones towards readiness level 3. That's the first time then you can really see that what you're looking after is also coming. And we are really happy to see now that all the different ground installations, ground tests that we've built, like for a fuel distribution system, which is very different when you take hydrogen, because you talk about liquid hydrogen, then cryogenic, so minus 253 degrees Celsius. that's very different from what we know today. So here we need to bring all the different bits and pieces together, and we need we are working as well with our partners from part of them around the table here. So here we have ground tests running on the distribution system. The next one is a tank to keep a hydrogen liquid at minus 253. That is a double-walled, very consistent tank. It cannot go in the wing, so this is making it very different. Here we have still not chosen the material, but we are looking into these tank designs. We've built the first ones. We are in the testing. Then we are looking into fuel cells, of course. We've put the first fuel cells together, managed to put 6 modules together to really play the full chain end to end, from hydrogen up to an electric motor using the energy, and that was today up to more than 1 megawatt, 1.2. So these are things where at each of the different sites we see things evolving now, and they're getting physical. So that's really promising on the path. Yeah. So that's to say, every single week and month we see things evolving now, which make us really very confident on the path. And that's actually totally in line with the roadmap that we've created, and where we will then need to choose the technology and the program, let's say in 2028, around that, and then mature it towards an entry into market.
Great. Okay. Thank you for that. Does anyone else want to come in on the potential and the barriers that will have to be overcome to make hydrogen work as a technology? Russ, do you want to come in on that?
Yeah, absolutely. I mean, so our focus on hydrogen is split between combustion and electric, and there are quite a few ingredients that sit between the two. I think in terms of technical challenges, I think the reality is that the efficiency of whether it's power generation through to distribution is going to be one of the key factors. How do you make sure that the energy that you take on the aircraft is used in the most efficient way, and less of it wasted as heat or other ways? That's why one of our key technology areas is about using cryogenics to cool the electrical network and the motor to reduce resistance and improve efficiency. We see that as a key enabler to growing the range capability that hydrogen electric at least can enable. In terms of challenges, I'd say actually the biggest challenge is not technical, although there are huge technical challenges still to overcome. But for me, it's more about the broader economic environment that needs to be created, so that technical solutions which are the most environmentally friendly are also given the economic conditions to be successful. And that, in a way, in a world that is diverse, in a world which has a level of conflict, and a world which has got different levels of sort of economic success, putting that in a fair way that enables those technologies to be successful. I think that's something that's going to take a significant amount of collaboration, through companies like ours, through governments and other bodies. I'd say that's the biggest challenge.
Okay, thank you.
If I could jump in.
Todd, please.
Yeah, so I think that, sorry, getting an echo here. So I think that it's very promising in that we continue to invest and build on the flight experience we have. I think there's at least 2 types of questions we need to continue to pursue. One is just on the aircraft emissions themselves, and understanding the total climate impact of hydrogen and some of the non-CO2 effects that also I think are relevant for other fuel sources as well. And then the other piece, I think, is in the infrastructure and the energy consumption, and both the generation of hydrogen, but in the distribution. Sabina talked about from a volumetric efficiency perspective, one would like to have hydrogen in liquid form, but it's not feasible to transport that over long distances in liquid form. And so what are some of the trade-offs? And that could involve also increased energy consumption in order to recompress it at one end. So I think it's this notion of we need to work each part of the life cycle and make sure when we add it all up that it adds to a total net positive.
Fascinating. Todd Giles, do you want to come in on that, and then I'll come to Luis Carlos?
Yeah, I would say hydrogen, all these things are very promising, right? We've talked about the technologies, whether direct combustion or whether fuel cells, right? And Honeywell is working on all of those technologies. In fact, we've demonstrated hydrogen combustion in the past, and we have an EU program with a consortium to develop the fuel cell, right? That is of a megawatt size or much larger, even to support, regional type applications, single aisle type applications. I think logistically and infrastructure is what's going to really drive. If you think about various airports in various countries, in various regions, one aircraft leaves one region, goes to another one that doesn't have or needs to have the exact same infrastructure, right? So if you think about the global network of aviation and commercial aviation and what you need to do and contingency planning and all those things, the infrastructure in my mind is what is probably the longer pole in the tent than necessarily the technology. Now there's technology hurdles, as we talked about, with how do I store it? How do I put it in a tank? How do I carry it all? What I need, the type of aircraft that can do that. All of those things are hurdles, but they're solvable. Infrastructure and retooling, regions, countries, the world, I think is one of the hurdles we will need to overcome here to get to the true net zero or true zero carbon emission.
Right. Okay. Thank you for that. Luis Carlos, your thoughts? You're just on mute.
Yeah, we also see hydrogen as promising as it's the it's the way to be really zero carbon, right? Provided you have a clean hydrogen. But and of course we're investigating fuel cells and direct burn. We also fully agree that feasibility is not only technical or technological feasibility, is economical as well as infrastructure. So this may define the pace of introduction at a large scale, the economics as well as the infrastructure. And the last point that was not mentioned, I would like to add, is that today we see the solutions using hydrogen limited up to a certain size of airplane, somewhere, in the middle of the single aisle or something like that, but not beyond. So we still don't have solutions to apply these technologies for bigger airplanes. That's why we need different levers and SAFs and all those things. And one interesting idea we have been exploring really is to also to use dual fuel. So you can use hydrogen for your let's say for your mission, and maybe use especially if it's direct burn, right? And then you can use so you use hydrogen for the mission, and then you can use, for instance, SAF for alternates, so that you make it a more efficient system. So the engine and systems providers, we would have to develop together dual fuel engines. So that's something that I believe will be very important for the future.
Great. Okay. Thank you. Let's move on to electrics now. I think all of you, in some way or another, are involved in the eVTOL or the UAM, AAM market. When it comes to slightly larger aircraft, we're all aware of the current limitations on batteries in terms of weight, in terms of range. And as we're seeing in the car market as well, there's the obvious challenge that, we have to produce enough electricity to have it available where and when we need it. So, without even focusing on the business case for electric aircraft, which is a whole webinar in itself, just looking at perhaps the physics and the chemistry, what is the potential for using electric power for commercial flight? Who would like? Let's go back to Sabine on that one.
Yes, just to have to find the mute button.
It's always a
technology.
technology.
And of course, so electrification is I don't know if you hear the aircraft passing by, but I hope it's loud enough. So electrification is, of course, a topic which will play a role. We talk about it in fuel cells, but that would be for 100% electrification. We can see as well 100% electrical flight in the more short range applications like eVTOLs, and we have our City Airbus Next Gen, which will be flying this year actually. How we look at the battery topic is actually, yes, we need the next generation. We need solid state batteries, that's for sure. So we have good collaboration, good partnerships, actually even beyond our industry to bring that forward. So we are working with car makers, for instance, to take their experience over the last decade, but then in preparing the next technology step, because otherwise it will be just too short in terms of energy density and weight efficiency and so on. And then I think an important question will also be volumes, because batteries, everybody wants them. So we need to have a path where we put a modular approach, and that's really what we are looking after, to be able to serve an eVTOL for 100% electric flight, but maybe have the same kind of energy that we put in a modular way on a big aircraft for a smaller application. And that's for micro hybridization or things like that. Because only then we can really be on a market with volumes and which are comparable to anybody of the big players in different other industries. So it is clearly a path that we play across the different platforms in order to be able to be competitive. And then in terms of the technology, we really need to look at the next big step, which for us is probably built on solid state.
Okay. Todd Citron, one of your roles is an oversight of Wisk, the eVTOL developer. But going beyond that, where does Boeing see the potential for electrification?
Yeah, great. Clearly, with Wisk, we've got considerable experience with 1,400 flights on our Generation 5 aircraft and working on Generation 6. So we clearly see feasible capability for the urban market. When you talk about the extension, there's a number of different technologies to enable that. One would be the hybrid electric, and if one combined the hybrid part with sustainable aviation fuel, then one has a sustainable approach to extend the advantages of battery electric to longer ranges. And then the other area that we're pursuing is with fuel cells. Hydrogen-powered fuel cells is another approach. So I think there's incremental technologies allow us to extend the range as we see improvements in the battery capacity themselves.
Okay, Todd, Russ, I'll come on to you in 1 second. Todd Giles, Honeywell, I know, has been involved in electrification technologies for many, many years. Where do you see the potential for electrification, perhaps beyond that sort of very, very small air taxi market?
Yeah, I mean, so obviously the advanced air mobility market, and its range and size class and things like that lead itself to electric propulsion, right? And so we are supporting that marketplace and developing that technology and working hand in hand with a lot of those OEMs to enable that vision. Now, as you move up that chain and you want to go bigger, more passengers, a little longer range, as Todd and Sabina, mentioned, right, you get into potentially this hybrid approach, right? Battery or fuel cell or even turbo generator, let's say, right? So we could take a turbo machine, run it on SAF and or hydrogen, in conjunction with a generator to provide distributed electric power for electric propulsion, any number of other systems, right? So we are looking at, different segments, different technologies for those segments to, enable different missions, right, to achieve different results. And so we're leveraging, our electric power, history and technology and everything else to bring it forward into these new technologies, new combinations, new systems, whether it's propulsion or power generation on that front. And then you extend that into, overall the more electric aircraft, right? Where can I use similar technology and sustainable technologies for environmental control systems, right? I can use vapor cycle systems using solstice, low greenhouse gas emissions to generate and cool the cabin. I can do the same thing with, cabin pressurization. I can do the similar things for EM flight controls. You start getting into similar technologies used in multitude of systems, to build up the most efficient system design aircraft. And so we're looking at all these, and we're working those technologies for very specific missions and segments within the market as you move up, let's say from drones to taxis to regional to single aisle to dual aisle, right? I think you're going to get different solutions along the way.
Exciting stuff. Russ, let's come to you on that question.
So I'm going to walk a very dangerous path of disagreeing with customers here. So I guess I've got a very different view, which is I absolutely do think sustainable aviation fuels is an important ingredient in aviation as a whole. I think the reality is, 35,000 aircraft won't immediately be able to transfer over to hydrogen. We're going to need sustainable aviation fuels. We also need to recognise that sustainable aviation fuels aren't zero emission, and even for the carbon, you still need to offset the carbon emissions with carbon capture, as well as NOx and contrails and so on. So my personal view is, because SAF is going to be constrained in terms of supply for quite a few decades to come, we're going to need to prioritise using SAF where SAF has the greatest impact. And the reality is, with kerosene today replacing the SAF, range matters. Longer range flights have a bigger impact. So from my perspective, I wouldn't be going anywhere near SAF for the smaller end of the market. The sort of ranges that we're looking at for AEM contributes 1 or 2% of overall global CO2 emissions. I would want that. I see that as being a born green market. We should absolutely focus on true zero emission battery electric. I think it's a great opportunity for aviation to enter into a new space in a purely environmentally friendly way. And I'd focus all of our range capability towards hydrogen electric capability growing, and I'd focus SAF on the larger aircraft where there's the biggest bang for your buck.
That's interesting. We've got quite a few questions from the audience on SAF, and I was going to talk about that later if we have time. But let's move to Luis Carlos on electrification. Now, you're obviously very involved with Eve, which is a spin-off of Embraer. What technological lessons do you think Embraer can learn from what you've done with Eve to perhaps develop that into other platforms?
Yeah, we have been developing Eve for quite a while, and before that we have flown our Ipanema, our crop duster, with an electric motor as well. By the way, since we're talking about sustainability, Ipanema has been certified 20 years ago, powered by ethanol. So we have been pioneers.
Pioneers.
Yeah, but we are learning a lot. We are talking about high voltage, so you have to learn how to deal with the high voltage and how to build a very safe. Our target for Eve is that it has a air transport type of safety, because it's a small machine, but it will fly over highly or densely populated areas. So of course we have to we are let's say developing and designing systems that are very safe but with high voltage. And one thing that is different from us that are used with big airplanes are the types of endurance and ranges. So we're talking about 30 minutes, 40 minutes. So it's a completely new world, and the certification bases are not yet defined. So this is one big challenge that we will all face when we go to fuel cells and other types of novel systems, which is to develop a product while defining the certification requirements you have to develop against. So that's an important challenge. But overall, we are very enthusiastic about Eve, and we believe, yeah, it will be 100% electric, 100% sustainable, zero carbon, flying in highly dense areas. So progressing well.
Okay, okay. Now, one thing I think a lot of our audience will be interested in is the process with which innovation happens within large manufacturing companies such as yours. Maybe you could just all explain briefly how your companies nurture new ideas. Is it top down? Is it bottom up? Is it a case of brilliant individuals or small teams leading the way, or a more consensual approach throughout the whole engineering cadre? What role do suppliers and R&D institutions play? I appreciate it's a complex subject to explain in a few sentences, but I'd be fascinated to find out just a little bit about perhaps about the process and the culture in your companies, how they arrive at your eureka moments. Sabine, let's maybe start with you on that one.
I think it's a brilliant question, and it's a very important one. I mean, we are all speaking for quite big companies, so it's a real endeavor to stay agile and innovative and being able to keep that spirit. So for us, the North Star is very clear, and even our purpose is driven by that, pioneering sustainable aviation and aerospace in a safe and united world. So it's clear that this is kind of our, the license to operate as we see it, getting there. Pioneering stays a very, very big element. And how do we keep pioneering even if we are a big company and with a great position today? And this is where we have really taken a choice in. We have the North Star, so we know for the next couple of years exactly all the different parts and pieces have to fit into that. And still, it's for us really a key point to learn very quickly. Build and fail quickly, learn quickly. So we are flying demonstrators, small demonstrators, and a lot of them. And that has started and by basically even a couple of different electric demonstrators a couple of years ago. So we have had a lot of learning in that we are using then going forward as well. What are the limits where we can go? What are the right voltages and things like that? And we have a kind of a startup tool in order to do so as well. So we have startup companies which are kind of a bit outside of the big, and where we place specific people, where we can better mix internal people with external knowledge, data-driven people, or really the new competences that we have to mix with the kind of existing ones, and then defining flying demonstrators to go very quickly to the limit. So, for instance, yes, we've just flown together with some partners, in this case, Daher and Safran, a fully electric aircraft, a little aircraft, in order to learn this whole chain. We also fly extra performance wings, so where we completely change the wings of in a kind of a 1/3 model of an A320 type of aircraft. So these are ways in order to stay agile, to stay quick, go faster sometimes as well, because then we don't need to look for certifiable aircraft types, but really go to the edge of where we can go and see the limits before we then bring that in a very structured R&D process. So we are building on the two.
Thank you, Sabine. Todd Citron, from a Boeing point of view, how does a company with tens of thousands of employees, thousands of engineers, how do you have that? How do you sort of have that culture where innovation has space to break through?
It's exciting. I'll start with that. But you can't dictate innovation, as I think is obvious. So from the, and I don't think you can drive it top down, but what you can do is set the vision and create the environment, to use the word culture. And so from a Boeing perspective, we have a pretty exciting mission of connect, protect, and explore not just this world, but other worlds as well. So we get a lot of excitement out of that mission statement. we have to create the environment where people have the time and funding and other support to pursue innovative ideas. And we have a number of internal mechanisms for that. And then we have to bring the outside in, because no matter how much we do, we can get set in our own ways. And so we have a number of mechanisms, from venture companies, just a whole gamut of investments and partnerships that allow us to bring the outside in. And in terms of the environment, it is really important to have the opportunity, both in those external companies and internally, for those rapid learning cycles to really progress. I think that's the value we've learned from software, and the great efficiency improvements from Agile can be applied across the board. And so we have a number of mechanisms for doing that. I'll just mention one, which is just in our 10th anniversary of the Eco Demonstrator, where we take a full-scale commercial aircraft and we target technology insertions on that aircraft each year to learn, to demonstrate new technologies. And it's more than demonstration, because sometimes that conveys just a one-off and put it on the shelf, but it's really testing to gain the learning. And the thing we're really proud of is with the projects that we've developed over the last 10 years on Eco Demonstrator, over a third of them show up in features on our aircraft, which is a pretty high yield of innovation converted into products. So it's really that combination of things: setting the vision, creating the environment, bringing the outside in, and having many opportunities to learn rapidly.
Thank you, Todd. And the other Todd, Honeywell, Honeywell is a company like any industrial company. You're having to meet production targets, you're having to manage supply chain, you're having to do it all profitably. How do you let innovation and product development come into that process? How do you make sure that you're always an innovative company?
Yeah, I think it is probably all levers, right? You asked about bottoms up. Is it top down? It's neither. It's everything, right? It's inside out. It's outside in. We partner with my OEM peers here, on the call to do co-invention, right? Well, what's the market telling us? What's our technology telling the market, right? Where could we go? Where do you want to go, right? So it's kind of all encompassing. What are startups doing? What are they thinking of that we're not thinking of, right? And so you kind of got to have a multi-pronged approach when it comes to innovation. But, as we talked a little bit earlier, right, the culture, you have to allow time for people to think. You have to allow time for creativity. Yes, you have to deliver on everything we've signed up for to deliver and support our customer base. But you also have to have the ability to get those ideas, then do something with those ideas. So we do specific events, right? We will create, a need. We'll create hackathons. We do all kinds of things. We down select great ideas, or what we think are great ideas, and we play the entrepreneurial startup mentality inside a very large company, and you give seed funding, right? And then you come back and you say what you learned. What else can you do? Is it promising? Is it not? Maybe it works, maybe it doesn't, maybe it moves to the next phase, maybe we pick another idea. You progress through that, and eventually it becomes a new program. So it's kind of that you take all information from all comers, you have a funnel of a zillion ideas, and they funnel down to, the 10, 20, 30 things that you really want to go full bore on. And then you make it a priority and you go execute on it. And so it's kind of the entire ecosystem of innovation requires basically everything we've all just said.
Okay, Russ, you're having to do it. It's not just about innovation, but it's about sustainable innovations. Everything that you're trying to do has got to have a sustainability angle to it. It's got to bring that. It's got to progress our whole sort of journey towards reducing carbon. How do you go about that?
So I'm glad you added that extra question, because that's quite useful to connect to. Our sustainability goals since 2020 have been broken into reducing our impact as a business, our emissions as a business, reducing our consumption of natural resources, and then enabling the future of zero emission aviation. And effectively what we do from a process point of view is that we insert in our technology process, in our commercial gate process, in our new NPI process, requirements that say you have to ensure you've done everything you possibly can to reduce the impact, whether it's on emissions, material, overall impact on flight. So we basically lock it into our process and we have goals around how much of our portfolio is invested in these things as well. So from a very process point of view, we have it sort of locked in. But I also agree with what Todd said. Ultimately, innovation comes bottom up. At least in our business, it's almost always bottom up. It's about us as leaders providing the right environment and giving people the headspace to be able to innovate. And when they bring innovative ideas forward, which we do through sprints, innovation days, those sorts of things, having the time to support and engage and give them the opportunity to grow their ideas and progress them. So I think we try and do a bit of both of those things. We standardize through process, we create the environment, and where we see great ideas and opportunities, we try to prioritize investment and support those.
Okay, thank you, Russ. And finally, Luis Carlos at Embraer, how does it work in terms of innovation and particularly sustainable aviation? Where do the ideas come from and how do they get nurtured?
Yeah, well, we are very fortunate to have a very strong innovative culture at Embraer. We were born out of an aeronautical engineering school and a research center that were created back in the 50s, and the company was created in 1969. So, of course, we work every day to foster this culture. But at Embraer, we work, I would say multi-directionally. Of course, I agree when we say it is bottoms up. We have to bottom up. We have to understand what are the creative ideas in the organization. But it's also top down for us. We do have a very structured process, a very structured governance. So we have buckets. We understand where we want to put the money. So in which buckets, which is linked to our strategy, right? And this is reviewed and updated and evolves. This evolves continuously, right? And then we have all sorts of vehicles. We have our Embraer X, which is our startup type organization. This is where Eve, our eVTOL, came from. So it was initially a seed there. We do have our corporate venture capital fund where we invest in startups. We have corporate venture building where we give money to people develop their own ideas. So we try to do a little bit of everything, and it's not only Embraer. The challenge, especially in sustainability, it's too big to try to do it alone. So open innovation with triple helix and so forth with academia, research organizations, and other companies.
Okay. Thank you, Luis Carlos. We're really running out of time, as I knew we would in this webinar. So many talented panelists and so many areas to cover. I've got a lot of questions from the audience. I don't think we're going to get a chance to get through a lot of them. We've got about 7 minutes left, so I'd ask you all to be very, very quick with this one. One of the questions that has come in is about advanced materials and aerodynamics as well, perhaps. We haven't talked too much about that. We did at the beginning. Who would like to come in and just talk a little bit, very, very quickly, about the potential for lightweight materials and aerodynamics in bringing about sustainable change? Sabine, perhaps would you like to come on that one very quickly? And then
leaving some time. So, and when I said, yes, we will need another 30% better aircraft, then of course we're looking to the engine, but we're looking to all of the components. And as you talked about materials and aerodynamics, so aerodynamics is clearly about the wing and how we do the overall configuration. And here there will be changes. So we are all looking for very thin, long wings. Then we might probably need to lead them flip up in order to cope with the airports. And then, of course, you can ask questions even about dynamics during flight. And then combining with this, of course, we need very potent lightweight materials. And I mean, this is a quest which is going over and over. And clearly, we are putting a lot of effort into the next generation of composite and everything which is coming up. So first is the material, and then is to use the everything it offers in terms of design as well. because I think in the early beginnings of composite, we did kind of metal design with composite, black metal, we call it. It is really now about having a much more integrated design using the advantages then of the new materials.
Okay. Todd Citron, very quickly, your thoughts on advanced materials?
I think advanced materials definitely, I mean, it's not just lightweight, which we're certainly continuing to make really good progress and coming up with lighter weight materials, but also high temperature. If we think about, friends that are providing the propulsion systems, the big benefits of ceramic composite matrix structures, materials, continuing to advance there, I think helps in many ways. So that's clearly important. On the aerodynamics, I'd just say, in addition to what we're visibly working on with the transonic truss brace wing configuration, there are also a number of other technologies that will help us further improve the aerodynamics. So the question's right on.
Okay, anyone else? Todd Giles, very quickly.
Yeah, just real quick. I mean, from the standpoint of now we don't play in the airframe of business from that material standpoint, but from a turbo machinery standpoint, right, it is all about more efficient cycles, right, which require different materials, higher temperatures, all kinds of different things. And then you get into whether hydrogen burning or not, and you need even more advanced material science going on in that phase. But I would also say, when we think of more electric and a lot of power running around an aircraft, thermal management then becomes very, very important, and how to make that as lightweight as possible and efficient as possible also. And so there's lots of research going on in how do we do thermal management with new novel materials in that segment to enable, megawatts of generation on aircraft if you're thinking electric propulsion. And so that is a very interesting, very exciting area.
Great. I'm going to ask you to be very quick, Russ, if you can, just on, I know it's an area that you're very involved in at GKN.
Yeah, I mean, we do lots of work on additive manufacturing, which is effectively making materials live in the process, and also composites and also on the cryogenics side. I guess my point is the materials are only really valuable when they're integrated into a coherent architecture where your manufacturing process gets the best out of those materials, where your design concept is optimized in a way that supports the architecture and leverages the materials in the right way. It works at a coherent integrated level. That's where you get the greatest value.
Great. And Luis Carlos, again, very quickly. 30
seconds. Now, when we talk about sustainability, we typically talk a lot about energy sources and power plants, but the airframes will have an important part to play. And so it has to do with advanced materials, aerodynamics. It has to do with systems we didn't mention, but novel systems to cope with, new configurations. So we have to invest in this as well. It will be an important part of the equation.
Okay, great. We're moving very, very rapidly to the top of the hour. We've got about 2 minutes left. So just to finish, I'm going to ask you to paint me a picture of aviation in 30 seconds or less as we approach the midpoint of the century. It might seem a long way away, but it's only as far away as the millennium is in the past. So, will airliners look broadly the same, with perhaps some evolutionary improvement under the skin, or will taking a flight in 2048 be a completely different experience to today? Who would like to start? Let's go for Todd Citron on that one. Looking ahead to 2048, very, very quickly.
I think there'll be a lot of changes. A lot of changes will be under the hood, so to speak, that you won't see. I think you'll certainly see some aircraft that look different from what they look today, but aircraft last a long time. So I think one of the keys to 2050, as opposed to beyond, is really how do we enable the existing installed base to operate much more sustainably, and I think that's possible.
Great. Sabine?
I also guess that we will see some new business models around, but then aviation and the aerospace mobility will be praised for being the cleanest in the skies and on Earth, and hence we will really be able to connect people even more than what we're doing today.
Great. Todd Giles, look to your crystal ball.
Yeah, I will say, if you look across all the segments of commercial aviation, I think you're going to both see evolutionary and revolutionary, right? So I agree with with my OEM peers here, but if you think from air taxi all the way to regional or even single aisle, I think you're going to see a broad spectrum of changes in technologies and aircraft, and it'll be a very interesting time.
Russ, revolution or evolution?
I think we'll see a transition away from significant hub to hub towards a more fragmented market, more customer choice, more opportunity for smaller zero emission aircraft, but a more diverse mix of aircraft and routes being flown.
Great. And Luis Carlos, your view of the future?
I believe it will be a very exciting time where we'll see different airplanes, different ecosystems, and different infrastructure. So after 70+ years of wings and tubes, we'll see a different landscape. It will be very exciting.
Excellent. Well, listen, we're on the hour. That brings us to the end of our first webinar of 2024. I'd like to thank once again all our panelists for engaging in such a fascinating debate, and thank you for joining us. Thank you also to Honeywell Aerospace Technologies for your generous sponsorship, without which this webinar would not have been possible. And as a reminder, a recording of this webinar will be available in the next day or two on FlightGlobal.com. I hope you'll join us for our next sustainability webinar in early June, where we'll be approaching the debate from a very different angle. And details, once again, will be on FlightGlobal.com in due course. So until then, thank you for watching and goodbye.
Thank you.
Thank you.
Thanks, bye.